Hello everyone, welcome to my channel Essentials of Electronics. In today's video, we are going to discuss about the special type of amplifier or differential amplifier. I'll draw this basic circuit of a differential amplifier. The differential amplifier has two transistors with their emitters being shorted together, and collectors are also shorted together with a common VCC. The emitter coupled to minus V. Let this transistor be Q1, Q2, RC1 and RC2. The base 1, base 2 will be fed by inputs. So let this be RS1, the source resistor, and RS2, the source resistance 2. Until now, I have not connected the input and the output. Why? Because this differential amplifier, we could operate it in 4 different ways, depending on the number of inputs fed. Single input, unbalanced output. Single input, balanced output. Double input, unbalanced output. And dual input, balanced output. These are the 4 different ways that you can connect the differential amplifier with. I'm going on to make out the first connection, single input, unbalanced output. Single input is connecting only one source, VS1 at a time, and collecting output across the other collector. Yes, this kind of output does not give a balanced output, it gives an unbalanced output. Yes, this is called single input and unbalanced output. Either way, you can connect VS2 alone and get the output across C1, then that is also called as single input unbalanced output. Next, I am trying to draw the circuit of single input balanced output. Let VS1 be the single input fed to Q1 transistor, and how do I get a balanced output? Yes, get the output from both the ends of the collector terminal C1 and C2, that is the output voltage signal is collected across the collector terminals of C1 and C2, then the circuit is balanced. So we have fed in a single input and a balanced output is obtained. Either way, VS2 can also be connected, that is VS2 alone is connected, and we could get a balanced output across the terminals C1 and C2. Yes, now I am moving on to get the output of the third category, dual input unbalanced output. How do we get a dual out? Dual input is supplying VS1 and VS2 to the base terminals of both the transistors. So dual input, but collecting output only across VC1 or collecting output only across VC2. That becomes an unbalanced output. I repeat again, dual input unbalanced output is obtained when you're connecting two input sources, VS1, VS2, but collecting the output either from collector terminal 1 alone or from collector terminal 2. Then the circuit gives you an unbalanced output. Yes. Now I'm moving on to the Fourth type of circuit connection, dual input and balanced output. So in the circuit diagram, both Vs1 and Vs2 are connected and collecting the output across both the terminals of the differential amplifier circuit gives a dual input and balanced output. This is the most commonly used type of circuit connection for differential amplifier. To note that the emitter resistor over here is connected to minus VEE, the VCC magnitude of VCC and the magnitude of VEE will both be the same. Yes, the differential amplifier circuit operates in two different modes. They are differential mode and the other one is common mode. Yes, differential mode and common mode. In differential mode, when do we call that the differential amplifier is operating in differential mode? When Vs1 and Vs2 are different. When Vs1 is not equal to Vs2, then the output voltage V0 is equal to the difference in Vs1 and Vs2 into the gain of the circuit. This gain is the differential gain. Yes, Vs1 minus Vs2. These are the difference between the input signals and it is given by Vd. Why Vd? The differential amplifier is operating in differential mode and Vd is equal to Vs1 minus Vs2 into the gain. Yes, V0 is equal to Vd into Ad. For example, if both the voltages are not the same, for example 24 volt is Vs1 and 12 volt is Vs2, then the difference of 24 minus 12 is 12 volt. 12 volt multiplied by the gain will give the output voltage of the circuit. Next is common mode. When do we call that the differential amplifier is operating in common mode? That is when Vs1 is equal to Vs2, we call that the differential amplifier circuit is operating in common mode. If we find the difference in these two voltages, then the output voltage will be zero. Hence, the differential amplifier identifies whether the voltages are same or not. If the voltages are same, they may be same in their magnitude and in their phase shifts or unequal phase shift, then the differential amplifier calculates the common voltage Vs1 plus Vs2 divided by 2. Hence, V0 is equal to Vc into Ac, where Vc is the common voltage. It is equal to Vs1 plus Vs2 divided by 2 and Ac is the common mode gain, where AC is equal to V0 divided by Vc. Now, by assuming some parameters, we will try to obtain some basic equations of the differential amplifier. Yes, assuming this source resistors Rs1 is equal to Rs2 is equal to Rs for the same ratings of Q1 and Q2. Yes, Re1 is equal to Re2 is equal to Re, and as said earlier, the magnitudes of VCC and VE are the same. Hence, RC1 is equal to RC2 is equal to RC. Applying KVL to the base emitter loop of Q1 transistor, we will be getting minus IB into RS minus VBE minus 2 IERE plus VE is equal to 0. Since IC is equal to beta IB and the collector current is approximately equal to IE, we will be getting IB is equal to IE by beta. Then substituting the value of IB in the previous equation, we get minus IERS divided by beta minus VBE minus 2 IERE plus VEE is equal to 0, and hence we get IE is equal to VEE minus VBE divided by 2 times of RE. This is the emitter current obtained in the differential amplifier circuit, and also VE is equal to minus VBE and VC is equal to VCC minus ICRC. The collector, the voltage across the collector terminal, but we know that VC is equal to VC minus VE. Then it goes like this: VC is equal to VCC minus ICRC minus VE is equal to minus VBE. Therefore, the output voltage VCE is equal to VCC plus VBE minus ICRC. Thus, the values of VCE and IE has been analyzed by assuming the parameters. And we have another important factor called CMRR, where CMRR is the common mode rejection ratio. It is the ability of the differential amplifier to reject the common mode signals. For an ideal condition, the CMRR should be high, and the value of the CMRR is equal to the modulus of the differential gain divided by common gain, that is AD is equal to V0 divided by VD, where VD is the difference in the two input signals VS1 and VS2. Under common mode, AC is equal to V0 divided by VC, where VC is equal to VS1 plus VS2 divided by 2, where VS1 and VS2 are the two input signals. So depending on the value of the gains obtained, the CMRR is calculated. The value of the CMRR is the modulus of AD divided by AC. When the differential amplifier is operating in differential mode, the emitter voltage is fixed and is equal to the common input voltage. The amplifier does not have any negative feedback and the gain is maximum. But when the differential amplifier is operating in common mode, the emitter voltage follows the input voltage variations. During this time, the amplifier has full negative feedback and has a minimum gain. So this CMRR can otherwise written as 20 log of AD divided by AC, and for ideal characteristic, the CMRR should be high. Yes, so in this video, we have discussed the basic operation of differential amplifier, the different types by which you can modify the differential amplifier and get the output. By assuming certain parameters, we have derived the equations for VCE, the common emitter, the collector emitter voltage, and the emitter current value IE. The CMRR is the ratio of the modulus of AD divided by AC, which is a very important parameter in differential amplifier. Observing the values of AD and AC when they are operating in differential mode and common mode respectively are obtained, and hence CMRR is calculated. Thank you.